This is question number 4, and it says, a researcher conducts a study on 2 independent groups and obtains a t-observed of 2.07 and degrees of freedom of 28. Letter A says, how many individuals participated in the entire study? So, in order to find the total participants in the study, you need to look at the formula for degrees of freedom. And the degrees of freedom is df equals n1 minus 1 plus n2 minus 1. So you see that you took away 2 points. So just add 2 points to your 28, and that equals to 30 participants. It's like going backwards. Letter B says, using a 2-tail test with alpha of 0.05, is there a significant difference between the 2 treatment conditions? So the first step is to find the critical value. So the critical value for this problem is plus or minus 2.05. And your t-observed, which was given, is equal to plus 2.7. So you need to look at the distribution to see if your t-observed is in the critical region or not. So I'm gonna draw my critical region. I mean the normal distribution by mean, which is 0. So this is my negative 2.05. This is plus 2.5. And then you go and see if your t-observed is in the critical region. So this is plus 2.07. So it seems that 2.07 is in the critical region. So we reject the null hypothesis. So the answer for this question is there's a significant difference between the 2 treatments conditions because the t-observed is greater than the critical value. Letter C says, compute R² to measure the percentage of variance accounted for by the treatment effect. So the formula for R² equals t² over t² plus degrees of freedom. Just apply your t-observed, which was 2.7 square over 2.07 square plus 28, and that equals to 4.28 over 4.28 plus 28, and that equals 32.28. So you divide it, it will be 0.13. And this is 13%.